Hello there. In today's video, which is a simple video, we will answer the following question. Express the following complex number in the rectangular form. Now, rectangular form means we want to find the answer and to write it as a real part plus an imaginary part. This is a simple question and it can be solved in several ways. I would think, for example, using a computer software to answer or to calculate this number. That would be an easy way. However, students should practice first to do these kind of calculations by hand before trying to do or to use computer softwares. Another method would be to take this bracket, this complex number, and multiply it by itself 6 times. Now this seems a long, tedious method. Sometimes it is, especially if the power is high, not just 6. 6 is okay. But it could be done. And sometimes we can notice a pattern when we try to do that, and we can use it to simplify the whole calculation. So let's try this long way to calculate the answer. So we want to find this bracket, this complex number, 1 minus I times square root of 3 to the power 6, which means we need to multiply 1 minus I square root of 3 by itself 6 times. Now, let's try to think how to do this. Let's take the first two first and try to find what is 1 minus I square root of 3 times 1 minus I square root of 3. Now multiplication will give us 1. Now this term I square root of 3 times the other one, those two terms will give us minus 3. And then the mixing terms, we're going to get minus 2i 1 times square root of 3. So the answer is negative 2 minus 2 square root of 3 times I. Or let's take minus 2 as a common factor. So it's minus 2, 1 plus I square root of 3. So that's the result when you multiply just two terms, two brackets. Now we could continue, but if we make a note, we notice that the answer is, at least look at the bracket of the answer, it's 1 plus I square root of 3. Which is the complex conjugate of the original complex number. So when we multiply two of those brackets, we're gonna get minus 2, a factor, times the complex conjugate of the complex number we started with. And that's a good note. We can use it. So that means when I multiply those two by another one, I'm going to simplify the answer because I'm multiplying this number by its complex conjugate. So I would say now I can do this calculation easily. The answer is, so the first two, I already have the answer. Multiply it by the third bracket, and that will give us minus 2 times two complex numbers which are conjugate of each other. And we know what is the answer for those two. So the answer is minus 2 times. Now, this number times its complex conjugate is 1 plus the imaginary part square. So it's the real part square plus the imaginary part square. So that is the answer for the first three terms multiplied by each other. Now, the last three terms will give us the same answer. So the answer will be times again negative 2 times 1 plus 3. And so the answer is 4 times 4 squared And so the answer is 64. Now, even though the method seemed to be long and tedious, at the end we used the fact that we get a complex conjugate of the original number to simplify the calculation. So that's a straightforward method. However, you can notice that if the power is high, this will become, it will require more work. The next method will be much more powerful, and let's go and try the next method using Euler Formula. Now, the most important method and most useful one is to use Euler Formula. So let's repeat solving this problem using another method. Let's write the complex number in a bracket using Euler Formula. So I got 1 minus I square root of 3 can be written as, in polar form you can say, as the modulus, let me call it R, exponential e to the I, the angle theta, where R is the modulus of the complex number, and by modulus we mean it is the square root of the real part, which is 1 squared, plus the imaginary part, which is minus square root of 3 squared. And that will give us 1 plus 3, which is 4, square root 2. So the modulus is just 2. Now to find theta, I will just use the simple form or method. Tan theta is the imaginary part divided by the real part. So it's minus square root of 3 divided by 1. Now, you notice that the real part is positive while the imaginary part is negative. So that means this complex number exists in the fourth quadrant of the complex plane. And that means theta is going to be in the fourth quadrant, and that will be negative pi over 3. That's the angle which has this tan. So now we already know that this number can be rewritten using Euler Formula as the modulus, which is just 2, e to the I times theta, and theta is negative pi over 3. Final step would be to take the power of this complex number, so 1 minus I square root of 3 to any power you want. In our example is to the power 6, is just now we're going to take the power 6 to this number on the right hand side. I'm going to get 2 to the power 6 e to the minus I pi over 3, and that's also to the power 6. Now the answer is 2 to the power 6, it's 64. And this exponential can be now rewritten as e to the minus I. I'm going to just multiply the two powers. Pi over 3 times 6, this will give us 2 pi. And let's simplify it one more time. I'm going to get 64. Now e to the negative I, 2 pi, will just give us 1, because that's cosine negative 2 pi is 1, while this sign will give us 0 using Euler Formula. So the answer is 64. That's another powerful method to calculate powers using Euler Formula. You could think of other methods, but usually Euler Formula present a very nice and straightforward and easy method to calculate powers of complex numbers. Thank you for watching this video. I'll see you in another one soon.